Hey, brother, hear me now. Brother dog, know me, understand.
Welcome to the Sargassum podcast. I'm Robbie Thigpen.
I'm Francisca Elmer.
And I am Mar Fernandez. And we are your hosts for today. And we are going to share with you the latest ideas and concepts about Sargassum and Sargassum beaching events which have become an international challenge.
Hi, I'm Robbie, and I've been visiting my co-host Fran here for a while. I've been doing a lot of research down here in Quintana Roo with my project, creating biocultural education materials in the lingua maya. And I decided to come over here and hang out at the beach for a little bit and see some nasty sargassum and some stuff like that. And we've just been having a real good time the last few days.
Yes, but we're not here to talk about your little vacation or work trip. We're here to talk about us wanting your feedback for our podcast.
Yeah, we've created this little survey we want you to fill out in the clip description below and all this here stuff. But fill that out. We want to know what you think. We started this. We didn't know what we were doing. None of us have ever made a podcast before. We're all on different continents and everything. And we think we've been doing an okay job, but we think we can do better. We have some ideas about how we need to change things in the future, but we want to hear what you think too.
So make sure you fill out the survey. You make us a huge favor in doing so. We really value your feedback, and please fill it out by the end of July.
Thank you much. We'll see you next week. Hey, good morning, everyone, or afternoon, or evening, wherever you are on the planet. We appreciate you showing up here today. My name's Robbie. We're talking we've got our co-host Cleo and President Henry, and we're talking to Teresa about arsenic. And just like all our podcasts, it's been brought to you by the Kimberly Green Latin American and Caribbean Studies Center at Florida International University. And also today we don't have a special another sponsor, but we're broadcasting to you courtesy of the Southeastern Veterinary Clinic. I had to run down here in beautiful Mount Pleasant, South Carolina. We had to come down here for an appointment for my puppy in a little bit, so they're allowing us to use their web to do this. I'm sitting in my Jeep, and so we're going to go ahead and get started. Anything you guys want to share today?
Yeah, I'm actually maybe also have a little sponsor because I'm not in Mexico at my house, but I'm actually visiting my friend Catherine. And Catherine is also a marine biologist, and she actually listens to our podcast quite a lot. So yeah, she's also letting me use her internet and also her couch to sleep on.
Nice. How about you, Cleo?
And for me, we're at 21, so it's the day of the summer, and also in France, it's the National Day of Music today. So, special day for me. But I'm still in Paris.
Excellent. How about you, Teresa?
I just want to thank you for inviting me in such a special day, La Fête de la Musique, and the summer solstice. So thank you very much.
Excellent. We'll get this thing started. Welcome.
I will introduce Teresa because we actually almost work together.
Oh.
So it's a pleasure to me to have you here today with us. So Teresa Chavez-Capilla is an environmental and bioanalytical chemist working as a postdoc at the University in Bern, Switzerland. She's working in the soil science unit within the Interfaculty cooperation project 1L, which looks at the microbial-mediated effects and transformation of different pollutants in the environment and across the food chain. Her research focuses on the microbial-mediated transformation of arsenic from food in the mammalian gut. She is specialized in studying the metabolism of the arsenic available to humans from the diet, including seaweed. And beside her position at the University of Bern, she is part of the coordination team of 500 women scientists Bern-Fribourg, an organization aimed to promote women in STEM. So welcome to you, Teresa.
Thank you, Cleo.
Teresa, so I'm originally from Switzerland, and whenever I go back home, I have to explain people what sargassum is and why it is such a big topic in the Caribbean and the tropics. But you are studying algae, so I wanted to know, being in Switzerland, have you heard about the sargassum influx?
Okay, so well, actually, I'm not studying algae right now, but I've been trying to get funding in the past couple of years to do so. So I've been reading more and more about the sargasso, and I mean, I know that it is a hotspot for biodiversity in the Sargasso Sea, but that there are like some blooms in the tropical Atlantic at the moment, and yes, since the past couple of years or even a bit more, and it's becoming a huge problem in the Caribbean and the Gulf of Mexico, and also I've seen that in the Canarian Islands there's also some blooms of Sargasso, and that I'm basically a species there. So I'm a bit familiar with that, but not an expert, of course.
Excellent. Well, I'm no expert either. And also, so welcome to the club. I got a couple of questions for you. And mainly, so what does sargassum mean to you? And this is something you study, you chose to study for a reason. So what does it mean to you?
As a chemist, specialized in arsenic, working in a soil science group, I guess it means like an opportunity to regenerate soils. So at the moment, there's a huge problem with our soils, and around 50% of the agricultural soils are actually have a very low fertility, and it is known that seaweed can be a potential to regenerate those soils. So for me, it's mostly an opportunity to actually apply my knowledge in soils, but my knowledge comes more from arsenic, so it's a bit more complicated. But how seaweed can be used in soils, but as well how we can mitigate the problems of arsenic related to seaweed. So I would say that this huge problem of sargasso in the tropical Atlantic, it could actually be an opportunity to be used to regenerate soils in certain areas where that is necessary. So,
well, thank you. The term opportunity comes up in a lot of our discussions here on the podcast, and it's always good that we hear that. It's rare when problems present opportunities. So we're thankful for that.
And speaking about opportunity, scientists keep telling us that we need to find before if the arsenic in the sargassum is organic or inorganic, because it's really an important question. So could you tell us what is the difference between the two of them?
Yes. Well, if we chemically speaking, that would have to do with the chemical environment around the arsenic atom. So arsenic is an element in the periodic table, and but in fact in nature we can find it forming like many different compounds, so arsenic compounds or arsenic species. So when we have carbon attached to the arsenic atom, we are talking about organic arsenic. Whereas if we don't have that carbon, we talk about inorganic arsenic. But the reason why you might be hearing that it's necessary to discriminate whether or not that arsenic is organic or inorganic, it has to do with the toxicity, because inorganic arsenic is associated with toxic arsenic and organic with non-toxic arsenic. But actually that's not really true. It's not always true. Like it is true that inorganic arsenic is toxic, it's actually a carcinogenic, and there's enough evidence to classify it as a carcinogenic for humans. But organic arsenic comprises a really big number of arsenic compounds as well, and with very different chemical structures, and some of those are quite toxic and some others are not. So I think it's not only a matter of looking whether or not there is inorganic or organic arsenic in Sargasso, but also to look at the more specific type of organic arsenic that you can find there.
Excellent. I think you may have more or less kind of addressed my next question, and that is how much arsenic is in the food we eat, and how is that a problem?
So, well, I guess it really depends on the type of food. So the main dietary sources of arsenic to humans are drinking water, which is a problem which is more known. But then in terms of foods, we can talk about rice, seafood, and mushrooms. So for rice, for example, the concentrations vary depending on countries. But those are around 0.1 to 0.4 milligrams per kilogram. And then seafood has usually higher concentrations of arsenic, so those can go up to 100 milligrams per kilogram. And then mushrooms is a little bit more tricky. There's not, there's not that much research at the moment as for seaweed and for seafood and rice. But some have reported concentrations quite high, like 7,000 milligrams per kilogram. But as well, in mushrooms, the highest percentage of that arsenic is an organic compound, which is called arsenobetane, which is probably the only one that I could tell you with certainty that is non-toxic to humans. But but as well, there are some regulations. There are some regulations in place to control these levels of arsenic in food, but they are not perfect. So, for example, for rice, the permitted levels of arsenic in rice in the European Union, they go up to 0.2 milligrams per kilogram, where I said that there's some rice that can have 0.4 milligrams per kilogram. So some types of rice can have higher levels. And as well, for seafood, I'm not aware of any regulations in Europe, but I know that in Europe, yes, but only in France. And that limits arsenic in seaweed only to 3 milligrams per kilogram. And then in New Zealand and Australia, those permitted levels of arsenic in seafood are up to 2 milligrams per kilogram. But the problem we have there is that those permitted levels are only considering inorganic arsenic, so they don't consider the organic arsenic that I mentioned before. And again, it's because it's generally considered non-toxic, but as I said, it's not always the case. So I think that's why it's a bit more important, not only for seaweed, but for everything in general, and more in general as well for seafood, to look at this organic arsenic.
Mm-hmm. So what does arsenic do to the human body when you ingest it?
So, well, regarding this, I could say more what happens to arsenic rather than what arsenic does, because what arsenic does has to do more with the toxic modes of action, which is not really my field of expertise. But basically, well, as I said, we ingest arsenic with food, right? So at the first stages of gastrointestinal digestion, or in the mouth and then stomach and small intestine, different chemical reactions are going to happen, which are going to release these arsenic compounds from food. So these arsenic compounds might become soluble in water, and they won't be attached anymore to the food matrix, and that means that they can potentially cross the intestinal barrier and get into the hepatic portal system, which means that they get into the bloodstream. So if that happens, they can access other organs, but more specifically, they can get into the liver. So in the liver is where the detoxification processes for arsenic take place. So usually the liver aims to make highly toxic compounds of arsenic into less toxic, and as well in making them more soluble in water, so then they can be excreted in urine. But if these compounds are if the liver doesn't succeed, to say it in a way, these arsenic compounds will go back to the small intestine through the gallbladder, and then further reactions will happen. But on top of that, we have to add all the microorganisms that we have in our gut, and those might play as well a role in transforming these arsenic compounds. and as well, if they are not soluble in urine, they will be excreted in feces. But within this process of transformations, we cannot always be sure that no arsenic will get into different organs, and as well, depending on how soluble they are in the fatty tissue or not, they can get accumulated in different parts of the body. So, yeah.
Yeah, it is bioaccumulation and moving up and down the food web an issue with arsenic.
Yeah, and I think it's more for marine ecosystems. So we'll have to distinguish between bioaccumulation and biomagnification, right? So bioaccumulation would be the accumulation of a pollutant, so in this case arsenic, within the lifetime of an organism. So in the marine environment, what we have is biomagnification, but then as well bioaccumulation, and that depends really on the chemistry of these arsenic compounds. So, for example, in the marine environment, we have an organic type of arsenic, which are called arsenolipids. So these type of compounds are lipid soluble, so that means that they accumulate in the fatty tissue, and they seem to accumulate to accumulate in the fatty tissue of fish. So they accumulate through the food chain, and then we might find them more in these fish that are higher up in the food chain. So we will be talking about bioaccumulation, but also biomagnification there.
Just thank you.
What are why would we avoid being exposed to arsenic? Because what are exactly the effects to our health of arsenic?
Avoiding arsenic exposure, I think it's pretty much impossible. But we could minimize the consumption of certain foods that have usually high concentrations of arsenic. But for that, there's already regulations in place, as I already mentioned, like these permitted levels for certain foods. But as I said as well, like these regulations have their limitations because they only consider inorganic arsenic, which has been widely studied. So then scientists are actually trying to provide more and more evidence on this organic arsenic, like all the wide range of organic arsenic compounds. But it is known that chronic exposure to arsenic, which means like ingesting really amounts of arsenic over time, can lead to certain health issues, like, for example, cardiovascular diseases or diabetes type 2, as well to certain cancers, which I think it's bladder, lung, I think bladder, lung, and there's another one that I don't remember right now, that can be developed by chronic exposure to arsenic. So I guess it's more limiting the consumption of certain foodstuffs that are known to have high concentrations, and until we find out more evidence, like the food authorities have more evidence to actually provide regulations towards this organic arsenic in seafood, for example, which is where we find it the most.
Okay, thank you so much. But so knowing that, if we want to avoid once again the exposure to arsenic, but doing valorization of Sargassum, like using this crisis as an opportunity, what products do we have to test for arsenic levels if made of Sargassum?
So I guess, I mean, it depends what those products are going to be used for and how Sargasso is used. I mean, for example, if certain active compound from Sargasso is extracted for a particular use, but then during the extraction procedure, it's really unlikely that arsenic compounds are going to be extracted as well. Then I guess in the in the manufacturing of this product, there's already quality controls in place to look for that. But if we are going to use the bulk of the seaweed for fertilizer or for feed of other animals, or to produce anything that is going to be in contact with food, then definitely I would advise to test first the concentrations of arsenic, and then if those concentrations are somehow high, then to look at the speciation of arsenic, which basically means to look at the different compounds of arsenic there, because, yeah, as I said before, it's really not the same to have a high concentration of arsenobetaine, which is non-toxic, than a high concentration of maybe inorganic arsenic, which is carcinogenic. So, and then as well, for example, if it's going to be used for beauty products that are going to be in touch with the skin, it would be as well good to look at that, because it really depends whether or not, I mean, I'm not very familiar with looking at the skin absorption of arsenic, but some of those compounds are lipid soluble, so they can maybe be absorbed to the skin, so it would be interesting as well to look at that. As well, I mean, I'm not super familiar either with all the many applications that Sargassum has, but it's important to know as well that bacteria, like we have microbes everywhere, right? And bacterial activity can actually degrade arsenic into something which can be highly toxic and volatile, which means that it's released into the atmosphere. So depending on where these type of products are going to be used, maybe it's worth looking at that. So I mean, it's pretty much everything, but
Thank you for that great answer, Teresa. I've got a kind of a convoluted question I want to ask you, because we're talking about the ocean, but even here in Black River, we've got signs on all the rivers east of where I'm from, all the way to the coast, and even on the coast saying don't eat certain kinds of fish because of mercury and other heavy metals and leads and stuff like that. And I contacted our Department of Natural Resources, DHEC, which we put these signs up, and asked them, what are these signs? What caused all this here? And they pretty much told me that this all came from burning fossil fuels, steam-generated coal plants, fuel, burning in our cars, diesel and whatnot. And also, this is, arsenic is a terrestrial issue as much as it is at the sea, as far as being in the food web goes. But is this in the sea? Is that more of a result of some of these, this really nasty crude oil that the tankers burn, or do we see larger local accumulations because of near the shipping lanes, for example, than we would in the open sea?
I'm not sure about the crude oil burners in the ocean, to be honest. But I mean, in general, the reason why we find arsenic in the ocean is by natural sources, right? Because arsenic exists in rocks, and then there's different ways that it can be released from rocks and get into water streams and soil and the atmosphere. So then there's deposition in the ocean. But I think usually in the ocean, it's mostly volcanic activity or industries that release atmospheric, like arsenic into the atmosphere, and then there's deposition afterwards. But I'm not sure if it's as much of the fossil fuel industry, to be honest. To that, I would not be completely sure.
Thank you.
Yeah, thank you for that. I always was wondering where the arsenic comes from and if it's natural or not. So, is Sargassum the only algae that takes up arsenic, or do other algae also have accumulation of arsenic?
Yeah, pretty much. I mean, maybe it's a bit too much to say all algae, because I don't know whether or not that has been reported in all of them. But since arsenic occurs naturally in the ocean, and usually it's inorganic arsenic is what is found in the marine sediments, pretty much all seaweed can, macro and micro algae can uptake arsenic, and then they can metabolize it afterwards into organic arsenic. So basically, the organic arsenic that we see in the marine environment is mostly produced, first produced by the seaweed. So there's different seaweeds that have arsenic, and for example, I don't know if you've heard Hijiki seaweed. That is the only one at the moment that is not recommended for consumption, at least in the European Union, because it has really high concentrations of inorganic arsenic. So that's one of the examples, but then there's others like wakame and nori and Laminaria digitata, which I don't know what's the commercial name for that, but we've been analyzing some of those in the laboratory. So they do contain arsenic, but as well, it's not always in the same form. So as I said before, like PGP has more inorganic arsenic, but for example, Sargassum, which is one of the seaweeds that I used during my PhD, has more arsenosugars, which is another type of organic arsenic that we can find in the marine environment, and it's basically the main type of organic arsenic that we usually find in seaweed.
Yeah, is that one of those organic ones that are a problem, or is it?
The evidence around arsenosugars is a bit unclear, because arsenosugars, so as the name indicates, it has like the structure as the building blocks of carbohydrates, so like small sugars, and these ones as such have been tested for toxicity, and they don't seem to be toxic in that structure, but because they have a kind of complex structure, they can degrade into other compounds while in the body. And these metabolites that they produce, they can actually be toxic. So the toxicity around arsenosugars is still a bit unclear whether or not they can be a problem. So it really depends on how they degrade. So, yeah.
Very interesting.
Awesome. Well, thank you so much for meeting with us today. And I hope to introduce more people. I personally have really enjoyed this. I certainly fascinated by bioaccumulation of different toxins and things. And I'm especially interested in heavy metals like arsenic and tributyl-10 and a lot of these emerging contaminants and estrogen mimics and their effects on macroinvertebrates or whatnot. So it's been a wonderful
Thank you so much for inviting me.
Just thank you for coming.
Thank you.
Nice. So what you guys think? You learned anything today?
Oh, I learned so much. Like, I don't know, it's just, I never really knew much about the arsenic. I was just told from the beginning, oh, look out because of the arsenic when you do stuff with sargassum. And then earlier we learned inorganic, organic from different people, but having this really in-depth conversation about what it actually means and that even the organic ones could be a problem, it was really, really interesting.
Yeah, well, I know you can't always tell it. I avoided biochem at university, and so I didn't realize there was an organic. I thought all arsenic was inorganic, and that was kind of neat to learn that.
Yes, and I think we also talked today about the fact that inorganic, of course, is toxic, but some form of organic arsenic are also toxic, and we just don't really talk about it. So this shows how important it is to study the different specification of arsenic in sargassum, and not just like, is it organic or inorganic, I guess.
Yes.
And also, I was really, I think I learned, and I knew, but I learned, we talk about the fact that we daily eat arsenic in our life. I mean, we are arsenic eaters, so maybe we do not love it. Maybe we should not eat it that much. We should reduce some high concentrated food of arsenic. But we do eat arsenic. So I think this
Yes.
is also a key point.
So maybe if you eat mushrooms or a lot of seafood, it may be as toxic as eating sargassum, where we don't know yet really how much arsenic is in the sargassum and if it varies between the locations and how much of it is the toxic kinds and the non-toxic kinds. So we always talk about how toxic, like how you have to look out for the arsenic in sargassum, but we never talk about the rice and the mushrooms and the seafood and the arsenic.
Well, I eat a lot of rice, and I didn't particularly care to hear that, but hearing about the hongos and the seafood, mariscos, that was the most disappointing part of this talk. And well, anyway, everybody, thank you for being here. You could have been anywhere else on the planet today, but you chose to be with us, and we appreciate you coming. We need to thank the Southeastern Veterinaria people here for letting you folks their internet, and we need to thank the Kimberly Green Latin American and Caribbean Center at the Florida International University for sponsoring this podcast, and we'll see you here again next week. And till then, catch a wave.
Bye, everyone.
Bye.
Thank you for tuning in today and learning with us from our guests. If you want more information about our guests talk about today, then please check our show notes for links and information in our archives, and don't forget to like and share our podcast with your friends.
If you enjoyed our podcast, please consider supporting us financially by becoming a Patreon. For as little as $1 per month, you can support us and get the exclusive benefit of being able to submit questions for our interviewees ahead of time.
The Sargassum podcast is produced by Marine Conservation Without Borders and is made possible with financial support from the Kimberly Green Latin American and Caribbean Center's U.S. Department of Education Title VI grant.
It is produced by Marcel Van de Kamp and our summer interns, Lauren Blankenship, Eloise Lopez, and Jenna Contucio, and hosted by Robbie Thigpen, Francisca Elmer, Mar Fernandez, Florence Menez, Cleo Meridakis, and Paula Diaz.
We will be back next week with another exciting guest. The music of this podcast is from the song Dema Pray by Drizzle Road Rana, an artist from Roatan. Follow him on Spotify or YouTube for more music. But for now, here is the full song, Dema Pray.
Hey, brother, hear me now. Brother, dog. Now me understand. Now for them no want to see we get nothing. That's why them a pray and always front and star. Now for them no want to see we get nothing. That's why them a pray. Now for them a pray. Them a pray. Them a pray. Me no gain progress. Now for them a pray. Them a pray. Me no reap success. Now for them a pray. Them a pray. Them a pray. Me no gain progress. Now for them a pray. Them a pray. Me no reap success. So me tell them yeah. Promises but man me no take that. Only if it come from Jah I'll accept that. Now for them me put me trust in and give me setback. Yo select that. Bill and pull up that. Tell some wicked that bad mind me no fear them. Anytime them cheat and chat me no hear them. Me dash a few hard soak for the queer them. Me dash a few hard soak tell them where them. Now for them a pray. Them a pray me no gain progress. Now for them a pray. Them a pray me no reap success. So me tell them yeah. Yes, me know me have a lot of fake friends, but me never woulda thought me woulda have fake family. So me tell them straight, me no trust them. Me no trust you and me no trust him. Fake friend lost bad mind in a real life. Nah, me no read that. God star, me no rate that. Me real for me water, bust a million shot in a real life. Now for them a free, them a free me no gain progress. Now for them a free, them a free me no reap success. Now for them a free, them a free me no gain progress. Now for them a free, them a free me no reap success. So me tell you, yeah. Screaming out loud, me woulda tell them fi go look alike, but them a hate and grudge and creep on mine. Them a move like Judas, them a move like Judas. Plus, everybody have a life to live, so me give one ras clock who a try judge me like them chit and chat. So what them want fi say, cause none of them out there nah feed. Now for them a free, them a free me no gain progress. Now for them a free. Them a free me to reap success. Now for them a free. Them a free me no gain progress. Now for them a free.